All right, so good afternoon, everybody. My name is Jesse, and I am with Exploring by the Seat of Your Pants. Now, all month long in January, we have been featuring amazing STEM careers. We've gone all over the globe, and today is no exception. We've already been to Cameroon to talk about environmental educators, to the UK to talk about a researcher who works in Antarctica at the bottom of the sea, and we just got back from California talking about going to space in a planetary geologist. So it's been an incredible month of programs, and I want to say a huge thank you to all our teachers live and on YouTube for continuing to join us in these odd times as we showcase and celebrate such amazing people and places from across the globe. So today, I am particularly excited to wrap up our big day with Karie Whitman. Over the last few months, we have partnered with the Duke Lemur Center in doing a slew of programs. I think 35 or more programs highlighting lemurs, conservation in Madagascar, and more. Today's is a little bit different from some of that. We've been joined by Karie before, and today she's going to talk to us about fossil lemurs, fossil preparation, how you extract those fossils, what fossilization is all about, and show us some of her cool tips and tricks in action. So, Karie, thank you so much for joining us today, and take us away.
Hello, I'm very excited to be here today. I'm in my office here at the Duke Lemur Center's fossil collection, and what I'm going to do first is just show you guys a little bit about how we find fossils and the general life story of a fossil from field to a museum. So I can bring up my PowerPoint screen and Jesse can share that with you.
Perfect. Okay. You're good to go.
Good to go. Okay, cool. So, life of a fossil. A fun fact about me is that I also like to do illustrations on the computer. So all of these things that you're going to see, most of them are from me. But a fossil goes through so many stages. First, we have to find it. So paleontologists, that's the people that work with the fossils, and geologists, the people that work with rocks, often work together to look at old geological maps and things and decide which part of the rocks is from what time on Earth. And when we know what time on Earth the rocks were deposited in, we can find fossils there. And a good place to look sometimes is where there's erosion from a river. So these layers of rocks were deposited over time. Some of them have fossils, and the river cut down through these layers of rock, and some of the fossils are visible now. So that's a really nice way to look for fossils. You'll see it a lot too in places that used to be oceans a really, really long time ago. And then the ocean bottom was lifted up over time, and the river's carved in there, something that looks like the Grand Canyon a little bit. And you can find fossils that way too. So once we find the fossils, after looking at the rock maps, then we find them in little pieces and we wrap them up in soft toilet paper or tissues and put them in a box so we can carry them back to our lab where we need to study them and take them out. So my job is to get the fossils out of the rocks. And we do that with lots of special tools that I'll show you in a bit. And we put glue on the fossils to keep it sturdy. And we also can glue some pieces back together if we're sure where they go. And then after that, a few more things happen. We can scan them, like how if you have a broken bone, you can get a scan to see inside your arm to see where it's broken. That's what we can do with fossils too, so we can see where all of the bones are. Sometimes we even do that before I take them out of the rock so we can see where all the fossils are and so I don't break them. And then after that, we can put them in a museum. And often, if the fossils are from a place that's not the U.S., we can return them to where they came from and put them in a museum there. Okay, so what I do as a fossil preparator is carefully get all of these fossils out of the rock. And so I have to sort of brush away the rock little by little, revealing the bone that's inside. Because the rock has kept the fossils safe for millions of years. That's how fossils form is millions of years ago, a bone from an animal that died laid on the ground somewhere or on the ocean floor. And over millions of years, it got covered with more sediment. And then slowly the bones were replaced by minerals from that sediment. So now it's a sturdy, mineralized fossil, and we can take it out of the rock. And here is a short little speedy video of me doing that. This is a skull of a primate that's from Wyoming. And so I'm using a tool called an air scribe that is like a little jackhammer, and it blows and vibrates so I can get a lot of rock off there. And I'm slowly moving toward the fossil, trying to make room so that I can get a lot of this rock out of the way. And once I do that, I'll flip it over, trying to get some more rock off there. So that's basically what it looks like, and I'll show you that live in a little bit. There we go. So that animal was called Smilodectes. It is a lemur-like primate from Wyoming. It's not a lemur, but they have a lot of similarities because they're really old types of primates. They're from between 52 and 47 million years ago. So that's pretty cool. And I'll show you that bone, and then we've got another relative of that one also in the lab. And just so you guys can see it, the Eocene is what we're looking at here. That is between 33.9 and 55.8 million years ago. And this is not necessarily to scale because you can see this is maybe about, 20 something million years difference. And then you get down here and there's millions, billions of years but down here. So really we're at the tip top of time on Earth, which is pretty cool. And the lemur fossils that we have here are technically subfossils because they're not older than 10,000 years. So they're pretty recent in terms of the geologic time scale. Okay, and I'm going to show you some of these guys in a little bit too. So we've got extinct Madagascar megafauna. And so they include the subfossil lemurs, like this big guy called Megalatopus, and this Paleopropithecus that was sort of moving like a sloth. We had a bigger carnivore type Fusa. We have a pygmy hippo, the little hippo, and some big birds. And we have eggs from the elephant birds here in the lab too that I can show you. Cool. So do we want questions now, Jesse, or I can just keep going?
I think you can keep going, Karie. We'd love to see some stuff in action, and then we'll take some questions at the end.
Okay. And I'm going to stop sharing my screen. Here I am. All right. And so I'm going to take you guys with me with my little headset here because when I get into the prep lab, it'll be a little bit loud. And I want you guys to be able to hear me. So first, here I come. And I'm going to set you on this desk with me so I can show you some subfossil lemurs. So here is one. This is the real fossil. And this is called Babakutia. He's a little, like a normal sized lemur that you would think of today. And something else that I do here is I can make copies. So this one's the real one, and this one is a copy that I made. And it's made of plastic. So that's kind of a cool thing that we can do is make an impression of the fossil, and then we paint some plastic in there and we can make a copy. So this is the big one. This is called Megalatopus. Sort of a gorilla-sized lemur. It was very big, lots of plant eating, which is pretty cool to know that even though there's about 100 species of lemurs alive today, and they're only in Madagascar, there are even more that have already gone extinct. So it's really interesting to think about what Madagascar may have looked like even 5,000 years ago. May have looked kind of different. We've got this guy. This is a copy that I made. And we've got some real fossil teeth over here. Wow, got to be careful with these. And then we've got one more to show you. This one is called Archaeolemur. And here's the real one, and here's the copy. And sometimes if I do a really good job painting, it's so hard to tell the difference between the real one and the copy. And we do copies so we can put them in a museum and not worry about the fossils breaking. But also if we need to send a copy to another researcher so they can look at the different characteristics of the fossil, like the size of the teeth and the shape of the teeth and all kinds of things like how far apart the little holes are. There's a lot that you can tell from bones if you study them. So that's what some of our researcher friends will do. Okay. So now I'm going to take you further back in out of the rock. And first, let's get some. So, whoop, caught my headphones on this chair. Okay, so this is where we keep some of these fossils temporarily while I'm working on them. And this is the skull that you guys saw me working on. There's this little eye socket. And underneath it's got all of these teeth. And I had to work very hard on some of these teeth to get all the tiny little pieces back on. Tiny little pieces. Very hard to see, but they're in there. So what I'm going to work on today is a leg bone. It's a tibia. And I can show you really quickly on this map that I have. So this is an example. This is not the exact same animal, but it's very close. And you can see that all of the bones are sort of laid out. This is a scan of how all of the bones were laid out in the rock. So you can see there's some of the leg over there. There's some here. There's his backbone. We've got some ribs. There's the skull up here. And so all of these bones are laid out in the rock like this. And then we go in with our tools and we can get them out. And then we can see what the animal would have looked like when it was living. Oh, and real quick, we've got an elephant bird egg in a lot of pieces. And this cool little nautilus that was an ocean creature that's also a fossil from Madagascar. Okay. And I brought my tibia over here. So first, let me show you my setup here and a lot of my tools. So here's my microscope. It's very important because there's lots of detail on some of these very tiny fossils, and I need to be able to see clearly what I'm working on. This is my air scribe. This is like the tiny jackhammer. It's not so tiny. There are bigger ones and there are smaller ones, but this is one of the small. It's on the smaller end of the range. And so when I turn it on, it makes this a very buzzy sound. So you'll hear that in a minute. I'm going to put you next to a screen that shows what I can see through my microscope. But first, we've got these little tools. It's called a pin vise, and so we can use that to scrape off the rock very carefully from where the fossil is. And then we've got these tweezers. So if a tiny little piece breaks off, I can grab it and I can put it back on. And the way that I put it back on is we have plastic beads that I dissolve in acetone. And acetone is what's in nail polish. So when you paint it on, the acetone evaporates and you're left with a hard nail polish on your nail. So that's sort of the same idea. These are hard when they start, and then we dissolve them, and then the acetone evaporates, and it helps us make our fossil more sturdy. It fills all the little holes with plastic. So that is the kind of glue that we're using to put all the pieces back together. And also something that's kind of fun is paleontologists work on teeth like dentists. So we've got dental tools so I can scratch and get all the dirt off from around those teeth. All right. So this is kind of the cool part, I think. And I will show you what it looks like when I'm getting a fossil out of the rock. So we got to turn on all these lights. And I'll get my air scribe ready, get my rock, very careful, put the bone where I can see it in this microscope. And I'm going to put you guys up here. And you should still be able to hear me because I've got my microphone on. All right. So, So that's the screen, and you can see into my microscope. I'll make it a little bit clearer for you. And I guess, Jesse, whenever we want to stop, just let me know, because I won't be able to see the screen, but I can hear you.
Perfect. Will do.
Okay.
Yes.
So I'm lowering my chair, And I'm going to make sure that you guys can see what I'm seeing a little bit clearer. Here we go. All right, so we'll zoom out. And then aim our lights. And you should be able to see it pretty clearly. That's the tibia. And it's a little bit broken, and that is typical for fossils because we don't know how they were preserved. And over time, sometimes they can get squished if the rock moves. And so this is a fossil that okay, look, we've got this little piece over here. That one I probably could put back in once I loosen it, and maybe goes over here somewhere. But other than that, we're going to leave it basically how it is. Because it's been squished over time, we don't really want to damage it further by trying to squish it back necessarily. So usually we just prep off the rock and try to be as conservative as possible with how the fossil is laid out. Okay, so I'm going to turn on my air scribe. And then we slowly try to get some of this rock to go away.
So again, this is so cool. Like, we're literally the first people alongside you to ever see this bone, this part of the bone, ever in history.
Exactly. Sometimes I take that for granted because I work on bones so much every day.
Yeah.
But it really is amazing because this bone is right between 52 to 47 million years old, and here we are touching it.
Yeah.
And so you kind of can work around, get a little bit of dirt off here, try to get some off this way.
You already highlighted some of these amazing species in Madagascar at the beginning, but I mean, to think that there were no humans around, there weren't even the precursors, like there were the earliest precursors of humans when this fossil was laid down. There were 20-foot sloths and saber-toothed cats and all these other incredible creatures back in the time when this fossil was laid down. The dinosaurs were long gone, but
right,
we're closer to the dinosaurs than we are to mankind in today with this fossil.
Right. So many cool things. And the best thing about Madagascar is that it's an island and it's been separate from the other continents for a really long time. So that's why it has such cool biodiversity of plants and animals and insects too, everything. So, and we'll turn that off for a second because it's kind of buzzy and loud, but you sort of get the idea. And then we can go in and brush some things. We can brush some things, and then I'll show you how we glue it. It doesn't need a whole lot of glue right now because I've been working on it, and it's already got a decent amount, but we'll bring it in. We've got a little pipette, and so I would go, oh, this looks a little bit broken. Let me get some glue in there, maybe in there, because we can see that there's some cracks. And we'll get it in there, and I guess getting the glue on sort of helps you see the color of the fossil better too.
Very cool.
Yes. And then we'll let that set. And really quick, I just want to show you guys another type of fossil. So that one is from Wyoming, and the sediment's very gray and sort of crumbly and not too hard to get through. But there's all different kinds of fossils. So this, if you can see, real hard to see. There's a tiny little white patch right here. And that's what I'm trying to uncover. I'm going to keep digging this way. But there's another side to it too, which I can find which block I'm looking at. Maybe this one? Yeah, there we go. So all of this is also a part of the bone of the fossil. And there's an impression over here of where, so this is a rodent jaw. And if you picture a rodent, they've got those big, long, curvy teeth that come out in front. So this is an impression of where that rodent incisor was. It's not with us anymore. We've got a little bit right here. But so I'm going to try my best to go around here, and let me zoom in even a little bit more. Okay, and then you can see there's a tooth right there.
You're back. There we go.
Oh, did I drop off?
Yeah, just for a quarter second, but you're good.
Oh, wow, weird. Okay. Okay, hopefully you guys heard me talking about the rodent incisor. It used to be here. There's a part of it. And then there's another little tooth right here. So that's pretty cool. And it's a little bit harder to see on this type of rock. And the rock's a little bit harder as well. So there's lots of variation in the kinds of fossils that we work on and try to get the fossils from. And Jesse, you can still hear me, right?
Yeah, we're all good.
Okay, great. I'm going to show you something real small. Okay, let me zoom in a little bit. So tiny. So this is something that I like to work on too, is even like the really, really tiny fossil pieces. So this is something that was broken. We have a collection from a place called L41, where the fossils have a little bit of salt in them, so they're really susceptible to breakage when they're in humidity, because the water makes the salt crystals sort of pop out and break the fossil. So these are some really tiny, tiny pieces of a little maxilla, so the top of the mouth of a tiny little carnivore. And I think a hard thing that people don't really grasp easily if they haven't worked with fossils a lot is like, how do we know what this is? Because it just looks so crumbly and tiny. But if you spent long enough looking at teeth and looking at fossils and the difference between fossils and rocks, eventually you can tell the difference. And I can tell. Is it still zoomed in? Yep. So this part right here is a little bit shinier. So this is the tooth. And this is the bone, the little pocket where the tooth is, and the tooth socket there. And this one also is a bigger tooth. This one's pretty shiny. It's a little bit harder than the rest of the bone. And so there's part of the tooth socket around that too. So I'm going to keep trying my best to get this puzzle back together to see what we can learn from that. But that's some of the smaller pieces that I work on too. I work on big things and really small things.
Very cool. Karie, this is so neat. If it's okay with you, we can dive in with questions. And if you're doing more work on camera, that's great. But you can answer some for us with our teachers. Does that work for you?
That sounds good. I'm going to turn off my loud machine and then I'll bring you back over here.
Awesome. Well, thank you so much for such a neat tour. The feedback on YouTube has been tremendous already, and we've got easily 200 and something kids from all across the continent: Alabama, Kansas, Alberta, Ontario, BC, beyond, Georgia. So welcome into all of you guys, and thank you so much for tuning in. We're going to go live to our questions first. We're going to go to Howard Robertson School, first in Ontario. If you want to kick us off with a question, come on in.
Hey, thank you. Thank you so much. This has been phenomenal. We have so many questions on this side, but we were wondering, one, how long would it take that first fossil we saw? How long would it take to fully dig it out? And just the other one was, what's your favorite rock to work with? Like, what's your favorite rock if you're like, oh, I got a fossil in this, rather than something harder?
Yeah.
Great. I don't think I've had that question before. So the first question about the time with this one with the tibia, if I was working really hard on it, like working on it all day, I could probably get it out by the end of the day. This one's not too big. It just depends on how much breakage there was, which hopefully there wouldn't be because I'm an experienced preparator and I like to avoid that. But yeah, I think I could get this one out. If I was working solidly on this alone, I could get it out by the end of the day, maybe a few hours. But some of the bigger pieces or the more even a smaller one, but it's a little bit more complex and it's in a lot of pieces, those take a long time to sort of piece back together. But yeah, it really depends. Wow. And so my favorite rock, actually, this kind of rock, this like texture, and it's sort of like a green gray flaky. I really like this kind because it's easy to see the difference between the fossil and the rocks. So we work with a lot of limestones and sandstones. And sometimes, like with this one, this is like a clay stone. So that's why it's so hard and red. I don't really like these because it's a lot harder to get the fossil out. And the fossil tends to be flakier. But in these types, the fossil is like pretty sturdy and easy to see in there, and the rock's not too hard. So
great questions, guys, to kick us off. I'm going to go to Legacy's class next. Cresty, grade 3-4. So you guys want to come on in? Go for it.
Hi. We have so many questions. I can only pick one. And Michaela wants to know, what is the biggest fossil you've ever prepared?
Ooh, okay, wait, can I share my screen with you for a little bit one more time?
Go for it.
I will show you.
Bring it up.
Okay, entire screen, and here we come. I'm going to show you guys this one. So this is a Basilosaurus. The name means king lizard, but actually it's not a lizard. It is a whale ancestor. And I went to the University of Michigan when I was in college, and that's where I started working on fossils. And I got to work on this Basilosaurus. It's about 70 feet long, maybe 60 feet, between 60 and 70. But I started working on these backbones, which were bigger than my head. So that's the largest I've ever worked on. And I really loved working on this. And actually, I loved it so much that I am a preparator still today. So
very cool.
Back to you guys. There
you go. Awesome. Well, great question, guys. I'm going to take a quick question from YouTube, and I'll keep going with our live groups for tons of time for questions, which is awesome. So Libby wants to know, she's joining us in Auburn, Alabama. She wants to know, what's the oldest fossil you've ever discovered? So we're doing all the superlatives. We did the biggest. What's the oldest?
Ooh. Well, okay, a lot of people find a lot of really old fossils, but me personally, the people that I've worked with so far have been looking at fossil mammals primarily. And so those tend to be within the range of these, like the past 50 million years maximum. A lot of the fossils I've worked with were 20-some million years old. But I have worked on a couple of dinosaur eggshells before, and maybe some teeth of some theropod dinosaurs, just really briefly. And so those would have been about 65 million years ago, I think, or more. So I have worked on dinosaurs a tiny bit, but only a little bit.
I'm glad you mentioned eggs too, because you briefly highlighted when you were walking through this elephant bird egg. I encourage everyone to look at it. It's the largest egg to ever exist. In fact, to my knowledge, the largest an egg can possibly be, like physically, based on how the structure of an egg is.
Yep.
36 normal eggs or some like it's more than that. It's like some crazy amount of eggs. It gets to be this big. Check out the elephant bird egg when you're done this program, guys. All right.
Yes.
Let's head to Georgia, to Jen and her family. If you want to demute your microphone, you're good to go. Come on in.
Go ahead.
How do you store them in a specific way to keep them preserved?
Yeah.
Oh, yes. How do we store them? That's a great question, too. So, yeah, I think am I tangled in my cords? I'm going to get up for a second, and I'll walk into the collection space a little bit more and show you guys some of our big cabinets and drawers that we have to keep all of our fossils safe. So we've got these wooden ones, which are a little bit old, and ideally we would be able to upgrade these because it's better to keep them in the kind that seal like this. We've got doo-doo, and it seals so the moisture can be kept out just a little bit, not a ton. But we've got all these boxes, these clear plastic boxes that we can see everything inside, and they're carefully labeled. We have our collections manager here at the Lemur Center that also very diligently labels everything and makes sure that we know where everything is from. And then we have foam that is closed cell foam, so there's no holes in the foam that the fossil pieces could drop into. So this is a safe way to keep all of our fossils contained. And in our other room, we try to keep the humidity out as much as possible too, because we don't want the humidity to affect the salt in the fossils and sort of blowing up some of our fossils from the inside with salt crystals. So yeah, that's how we store them.
Fantastic. Thanks, Karie, and great question, guys. All right, we're going to head to Calgary to Miss Stam's class for flies. If you guys have a question for us, just demute that microphone and you're good to go. Hi, guys. Welcome in. Hi. We just need to get your mic unmuted. Oh, that's the camera. There we go. Hi. I can hear you. Yeah, just a little bit. A little echoey.
How do you know the fossil bone goes with the animal bone?
Yeah.
That's a great question. So we always just start from the ground up, literally. So we see a thing, we're like, this looks like a bone, and then we dig in a little bit more, and then we see different shapes and variations of how the bone looks, and then we compare it to bones of animals that are alive today. So that's a really important part. We could tell better sort of based on what was next to it, and by the fact that it's a long bone. There's only so many options for a long bone. So then we can look in the scan. When we scan it, there's more down here that I'm going to get out later. And sometimes when you find a fossil, you can't tell what it is exactly, and that's okay. And so not every fossil is going to be super loaded with information for us, but something like this skull is loaded with information because we can see the size of its skull. We can see all of what its teeth look like. Yeah. And so people that study teeth know that the shapes of the teeth tell us a lot about what the animal was eating. So you can tell a lot about how an animal lives by looking at its teeth. And with its other bones, we can compare it to lemurs, because we have a lot of lemurs here at the Lemur Center. And then we can compare those bones and see, oh, this animal is a little bit like a lemur. And that's what we do with everything that we find too. So we don't always know what it is when we find it, but then we clean it up and we keep looking and we keep researching and comparing, and then we can tell a lot about it.
Very, very cool. Thanks, Karie. And I just encourage all our students to check your own teeth. This is something that I love when biologists bring up. We have some sharp teeth near the front and some slicing teeth, so we can cut through fruits, we can cut through meats. And in the back, we have those big, thick molars that can crush things like nuts, other plant matter. So we're omnivorous, and you can tell that from our jaw. If you look at a dog's mouth or a cat's mouth, it's quite different from ours, and it reflects what they like to eat. So just check that out when you get home, or check that out right now if we want 200 kids touching their teeth all at once. How fun would that be? I'm going to a couple quick questions from YouTube, and then we'll go to our other live classes. Ms. McIntosh and Ms. Rincon in just a minute. So Mr. Hergut's class, they want to know on the rock hardness scale, and I haven't thought about this since I was 7 years old. What is the hardness of different fossils, and what kind of rock are you doing? So I guess Mohs hardness scale, diamond's a 10, talc is a 0 or a 1, if I'm remembering. Where are your fossils at?
This is a very interesting question. I don't know if I've thought about that in a long time either, but definitely not as hard as a diamond. So what this tip is made out of is carbide steel, just some pretty sturdy carbon. And so anything that can be broken by this is automatically softer. So it's definitely softer than diamond. It's definitely softer than carbide steel. And it's definitely harder than talc. Sometimes not that much harder, though. It really depends on the fossil, but sometimes they flake pretty easily. This one's sort of a middle of the road, but because of this limestone type thing that it's in, the limestone's really flaky. And so this is just a little bit harder than that.
Yeah, very, very cool. Thanks, Karie. All right, one quick question from Genevieve in Oshawa, our student who's joined us for more programs than pretty much anyone over the last year. She wants to know, how do you know where to dig the fossils? How do you find these in the first place?
Great question. Let me go show you some of these maps. We've got geologic maps all over the place in this building. There's one of North Carolina, but I'll show you a couple of others. So geology is really important in finding fossils, and we wouldn't necessarily know where to look if we didn't know about all of the layers of rocks. So there's years and years, decades of research from geologists and other researchers of every kind. And so they test all of the rock layers and map them out and determine what formations end where and how old that means they are. So when were the mountains lifted up in America? Or when did the land of Madagascar come and be above the water? So we've got a little bit of mountainy stuff over here, some plateaus, and then stuff that used to be under the ocean over here. So that's where we can find more dinosaurs and things. But it's really important to look at all of these layers of rocks and how old they are, and then estimate where you think you could find different kinds of fossils. And so here in Africa, This is a good example. There's a rift. So that means the tectonic plates are moving apart very, very slowly. And then there's a gap that's forming over here. And so that leaves a lot of like rock cuts where we can look for things. And we don't always know how old they are until we go there and study it. But the rocks tell you most of what you need to know.
Very, very cool. Well, thank you for the map view. That was awesome. All right, let's go to Miss McIntosh's class in Toronto, and then we'll go to Miss Rincon in Edmonton. Miss McIntosh, just demute that microphone, and you're good to go.
Hi from Toronto.
Hi.
We're very excited to be with you. And we just finished our rock and mineral unit, so it's really cool to see the sedimentary rock in action. So that's really cool for us. I have some dinosaur lovers, and we want to know, can you find dinosaur bones all around the world? And I know you said you mentioned you worked on a few dinosaur bones, but any other dinosaur bone stories? Because we love dinosaurs.
Good question. Yes, you can find dinosaur bones all over the world. It just depends on where specifically you're looking and how old the rocks are. But we've got lots of dinosaur fossils found in the United States in places like Utah and Colorado. Everywhere, I assume. There's some from New Jersey, I think, too. But there's dinosaurs from China. There's dinosaurs from Madagascar. There's dinosaurs from Africa. There are dinosaurs everywhere. They're just different kinds of dinosaurs of different ages, depending on where the rocks are. Dinosaur stories. I'm always a little bit disappointing in the dinosaur realm because I haven't worked on that many dinosaurs. I have worked on some bird fossils, and birds are living dinosaurs.
That's true. We got that unexpected message in our lemur talk today. Birds are dinosaurs. Love it.
Yes.
No worries if you have no salient big dinosaur stories to begin with, but I want to stress for our classes too, not just the places Karie mentioned. We just had an Antarctic program earlier today, and Antarctica used to be a lushly forested continent that did not used to have all that ice, and there's some really, really amazing dinosaurs we have found in Antarctica, so do check that out when you're done the broadcast if you're keen.
Yes, that is true. That's very cool too.
Cryolophosaurus is the favorite. He's like a little frill. He's like T-Rex with a frill. Yeah, it's very cool. All right, Ms. Rincon's class joining us in Edmonton. Thanks for coming in finally. This is so exciting to have you live instead of just on YouTube. But welcome in.
Yeah.
And, yeah.
Hi. I don't know if you can hear me because I'm wearing a mic and we're here in class, and so don't mind the mess back here. But we are impressed with the questions coming in from other classes, and we are in Alberta, so we love dinosaurs as well. But our questions are actually for Karie because we are kind of studying careers, and so my students would love to know, if you have an answer already, what inspired and influenced you to want to discover fossils, and also, we know that you're in the lab and giving these out, but do you ever have to do any field work or research?
Yay, both really good questions. I might share my screen with you again for a third time, just really quick. Here we come, and whoop, there we go. Okay. I have a pre-made little thing right here that sort of outlines how I became a fossil preparator. It's a little bit wordy, but just hang with me for a second. So in college, I was studying ecology, which is all about the environment and animals and how they interact. And then I was interested in evolution as well. I always thought it was interesting how animals came to be how they are. And so in college, I was looking for a work study job in a lab. And one of the options I had where I interviewed was working with those big whale fossils that I showed you earlier. And I just thought that that was the coolest thing. So I kept doing that as my work and became really interested in getting fossils out of the rock and the shapes of fossils and everything like that. But in my studies, I kept being interested in sort of ecology and the environment, which relates to because fossils do tell us about the environment of the past. So that was always really interesting. So I sort of did a diversion where I went to work as an environmental technician in AmeriCorps, letting people know about invasive species and healthy shorelines and things like that. But then I still liked doing fossil prep, and I went there after that. So I'm always between environment, ecology, and doing work with fossils. So then, while I was working as a fossil preparator in Ohio, I went back to grad school to get a master's in environmental studies. And then I actually went to Madagascar for something very different, which is research on sustainable rice agriculture. There's a lot of farmers in Madagascar, and a lot of them grow rice. And it's very important to make sure that people in Madagascar have enough to eat so that conservation of the lemurs can continue. So I got experience in Madagascar, speaking the language and things like that. And so that landed me here, which is a perfect job for me at the Lemur Center, because I get to do fossils and I get to still think about the environment sometimes, especially in Madagascar. And we will hopefully go look for fossils there again once COVID stuff clears. We're hoping to go back to Madagascar to look for some fossils, but I might also be able to look for some in the US too. And oops, I'm freezing.
That's okay. We can see you again. So take your time. We're getting out a screen share.
Okay, great.
We're going to take one more question. I wish we could take so many more. We're nearing the end of the broadcast. Time flies when we're having fun, people. So I'm going to just pick at random. Howard Roberts in school, if you guys want to ask one more question, come on in and wrap us up.
Hi. Yeah, thank you again so much. We were just wondering how the animals, like the megalopodus, how do they get their names? Like they have awesome names. Elephant, bird. Like, just do you know how they got there?
Yeah. So specifically, technically, the way nobody says it like this, but if you're talking about the roots of the words, adapus is a word that comes up in a lot of primate scientific names, and so like megalodapus is just like big primate, really. And so, yeah, the names of animals are kind of weird sometimes. It's more useful if they tell you about the history of the animal, like Paleopropithecus. A Propithecus is a type of lemur that's alive today. So if we call it Paleopropithecus, it means it's like an older version of that, which is informative. Archaeo lemur, same thing. Archaeo is like an old lemur. So all of these are pretty literal. Babakutia is a cool name because the Malagasy word for Indri is the big black and white teddy bear looking lemur. The Malagasy name for that is Babakutu. So they call this one Babakutia after that. So sometimes people name fossil animals based on where they found them or based on what they are, or sometimes people even use like last names of people that they admire. So there's lots of ways to name fossils.
Yeah. Very, very cool. I've never had a question quite like that, although it does harken back to one of our first presentations today where we were talking about an Antarctic scientist where some species are actually named after him, like being alive. That's the coolest thing. If you're alive and you get things named after you, that is a good sign you're doing some cool work.
Yes.
Karie, this has been so much fun. Again, I wish I could take more time to answer questions, but what I do want to do is share with everyone lemur.duke.edu. Check out the Duke Lemur Center's website. Amazing resources, more on the work that Karie does, more on the entire work of the institution. It's an amazing organization, and you can learn so much more there and help contribute to their efforts on their website. And then if you want to hear from more incredible women like Karie, February 12th through 14th, we are doing our Women Blaze Trails Fest. 50 programs in 3 days, all celebrating incredible women in STEM. So check that out, all for free. We're running it as a fundraiser, but you can tune in no matter what. And we'd love to have you guys join us. Karie, this has been such a thrill today. Thank you so much for joining us, and I really appreciate you taking the time.
Yay. Thank you so much, everyone. It was really fun for me too. And if you have more questions, hopefully we'll do this again, or you can send an email through Jesse or through the Lemur Center, and somebody can try to answer it.
Lovely. If people want to send me an email, you're welcome to do so, and I'll pass it along to Karie. We can inundate her together if we'd like to. What we do at the end of every broadcast, as you know, is I'm going to bring in all our groups live. So our Howard Robertson School, Crestview, Jen, Miss Stan, Miss McIntosh, Miss Rincon, everybody's in. Welcome in. Thank you so much for joining.